Trevor Dueck. I work with Shell Canada, and then today I'm just going to talk about our local sites perspective and what we saw, some of the benefits that we've gotten from virtualizing our DCS, and just how it helped us reduce our maintenance effort and reduce the downtime. So I work at a facility near Edmonton, Alberta, Canada. If I took the picture today, it'd probably be a whole lot whiter than what it's showing now, and that's kind of why I'm here in Florida. But it's a large facility. We have an upgrader that's a 250,000 barrel per day facility, as well as a 100,000 barrel per day refinery and a chemical plant. And so as far as the agenda of what I'm talking about today, I'll be speaking on, I guess, just speaking on what is virtualization. From this conference, it seems like most people are very tech savvy, but for those that don't know, just do a brief overview of what that is, and then speak on some of the benefits that we've seen realized at our site, as well as discuss some misconceptions that I've seen people have about virtualization. And then finally, I'll just go through our project and just some of the architecture that we use for our DCS virtualization. So first, what is virtualization? Essentially, you're just a way of decoupling your software from your hardware. So it allows you to run multiple virtual computers onto one physical server. So traditionally, with a DCS, for every application, you would have to have a physical computer or server to run that application. So for every operator station, you need to have a physical workstation to correspond with that. So with virtualization, you can compile many of these into one physical server. So at Scotford, we have up to 10 VMs per physical server. And we also use a mixture of Hyper-V and VMware technology. And then as far as some of the benefits that we've seen at Scotford, the first one is redundancy. And I guess just to be clear, I guess redundancy is not necessarily directly related to virtualization. Like as an example, you could have 20 servers and decide to virtualize them all and throw them into one single server, and then all you've ended up doing is putting your eggs in one basket. So if you lost that physical server, you now lost 20 machines. So when doing this, you need to have a properly engineered solution so you have the redundancies built in where you needed them so that you don't have the unplanned downtime. So yes, for our design, all our key components were redundant, and then anything that's non-redundant were off-the-shelf components, such as thin clients, where they're just very simple setups. You can have them installed in minutes. So if they were to fail, they're up and running right away versus the hours you typically would have had with an operator station restore. We've seen some benefits with upgradability. The hardware now is able to be replaced with very minimal operator impact. And also, our base hardware is not as constrained with the DCS qualifying limitations. So yes, typically with DCS, you rely on the DCS vendor to qualify their software to run on a certain Windows OS. Because your base physical software is now just straight Windows, that can stay a little bit more current than maybe your DCS actually is. And as well, because your virtual machines are also easily upgradable. You can upgrade them all in an offline environment and then just throw them into the live system. Some other benefits are the backup and restore capabilities from virtualization. You can take snapshots, and this allows you to quickly revert back in seconds if there's any issues with any patches or updates that you are doing. And this is in comparison to the hours that a typical restore would have taken on a physical server. We've seen some great improvements on our maintenance. Just some small things such as the time it takes to reboot a VM. It seems pretty small, but when you think that those physical servers could take 10 minutes or more sometimes to come back up, when you're installing software for 60 machines or doing updates or Windows patches, that time savings there is huge. Like I would say we save days of time when we're doing our initial install. Patching and updating can now be done in the background, and then your impact to operations is now limited just to the time for them to log off and log back on. And then as said with the backup restore, you can revert back if needed. And also another improvement is the management of these VMs. It can be done with a central console. So if you're doing any work on these machines, you can now do it in the back room, as to the prior experience of always having to be out in the control room, taking over a few of the operational screens from the operator while you're doing your work. Obviously, if you're consolidating a bunch of servers into one physical server, you're going to also have a large reduction in the infrastructure that's required. You reduce the amount of rack space that's required, as well as your HVAC and power requirements in your buildings. In one example, we've seen one of our server rooms UPSs go from 75% to 45% loaded. You have improved testing and troubleshooting capabilities. It's very easy now to take your VMs and throw them into these offline environments and perform all your testing on the actual servers that are out in the plant. And then another big benefit is that if you're having a more significant issue, you can take that exact VM and send it to your vendor for the advanced troubleshooting that's needed. So then it's very easy for them to replicate the problems that you're seeing. And finally, with these big physical servers that you're having, you can now take advantage of that extra horsepower. Because all the resources are shared among the VMs, if you have a very resource-intensive application or server, you can allocate more of the memory, disk, and CPU usage to that one server and properly share those resources. So now just some misconceptions of what virtualization is not. It is it's not always current computing. I've heard it said that you can just throw your VMs in place and then now all you have to do is worry about that base physical server. All your VMs are still computers, they're still running Windows, they still need the same patches and updates that they would have in the past. There's also not a way out of upgrading. I've also had that comment where you might have this obsolete piece of equipment and it requires Windows XP or something older to run. And I've heard the comment said, well, just virtualize it, then you don't have to worry about it. But yes, that might get rid of the risk of the hardware failure, but you still have that serious risk of the unpatched Windows obsolete OS. For our project, we found that it wasn't actually a cheaper initial cost. It was roughly the same whether we went virtual or physical. But I think our savings are more in the maintenance reduction and the efforts to maintain this in the future. And then finally, I know this is similar to a lot of the stuff we've been talking about this week at the conference, is that this technology is not the same as before. You will need a new skill set on that OT environment to manage this and learn how to deal with more of these IT type technologies. So now just as a background into the DCS state at where I work. I was helping manage the refinery and the chemical plant at our site, and we're running a Schneider Electric Foxborough DCS. So we had about 60 DCS servers, engineering servers, and operator workstations, and they're all obsolete and they're beginning to fail at a very unsustainable rate. It was becoming hard to repair them fast enough to replace them. So this obsolescence and those subsequent failures were creating a greatly increased risk of production downtime, and it was leading to reduced operational KPIs. So to mitigate this risk, we decided to implement a project, and we decided that virtualization was going to be the best solution to reduce this risk of downtime, as well as position our facility for success in the future. So that's a very simplified architecture. As you can see, we went from, just showing the switches, thin clients, and the servers. We went from 60 physical machines down to 10 servers. In the orange are the 3 servers that are hosting our engineering servers, and then in the blue, that's demonstrating the physical servers that are hosting our operator stations, and kind of the redundancies that are shown there. So for every operator main control room, we have 2 physical host servers that are running the operational workstations. And so as a sample console, what you'd have is you have 2 thin clients, each of them with 4 monitors, and each thin client talks to its own VM on its own physical server. So the operator has 8 screens to control their unit with. And then in the event of a server failure, that thin client will automatically reconnect to the backup VM on the alternate server. So his downtime is now limited to the time it takes for him to log back into his server. So you have seconds of downtime, and now all the screens will be functional, and it'll give the maintenance or systems team the time it takes to repair or replace the physical server. And then as far as implementation, with virtualization, we were allowed to do all this upgrades on the run. In a refinery facility, it's very critical to be able to do this kind of tasks without requiring a shutdown, because we obviously rarely shut down. So all these VMs were able to be pre-built in an offline environment, fully tested and running. And then our downtime was the time it took for us, or interruption was the time for us to physically change out the monitors because their form factor changed, and then add the thin clients. And halfway through this project, we actually saw one of the benefits of virtualization quite quickly. The base OS of the Hyper-V server was, the supportability changed halfway through the project, so the newest Windows was supported by the vendor at that point. So we were able to take advantage of those redundancies that I talked about in the previous slide so that we could migrate the VMs back and forth and enable us to upgrade all our physical host servers on the run with very limited operation disruption. So in conclusion, we've had significant success with virtualization at Scotford, and we've seen some great business value there. It helped us reduce our maintenance effort. We now have a reduced downtime from many unplanned failures, as well as a reduced impact from obsolescence. Thanks.